everybody, welcome back. It's good to see you. I hope you can see me here. I've got the whiteboard today, and we're going to do a little bit of just basic electrical diagnostics on a transmission. This isn't any particular transmission. It basically is just a generic explanation of how the electrical side of a transmission works, okay? I see a lot of videos with O2 sensors and fuel trim, drivability, brakes, wheel bearings. I don't see a lot of transmission ones, except for the ones with the automated computer voice. All right. So I kind of want to break this down, give you an understanding whether you're looking for a mechanical problem or electrical problem. So many times customers come in, I was told it's just a solenoid, Well, we can narrow that down, and I'm going to show you how. Okay. So let's start off. I'm sure I got my colors here. What I've got here, you've got a battery, you've got a PCM, you've got a PDC, power distribution center, where your fuses relays live. These aren't to scale or anything, it's just for explanation. And you've got a valve body on the transmission, okay? So we'll start with the battery. You've got power and you've got ground, which all electrical components need power and ground. It has to complete a circuit to come back, okay? Typically, a lot of vehicles, your ground will go to a ground, and they're spread out, body grounds all over, engine grounds. Right from there, there's a harness. So this is a body ground right here. And then we've got power coming out. You see, it goes through the PDC, power distribution center, and there's a fuse in there. And then it goes to the PCM. And then the PCM internally will deliver powers and grounds. Now, on domestic vehicles, Ford, Chevy, Dodges, typically they're going to use a ground-controlled system. They are supplied voltage all the time, and the PCM with ground drivers will actually control the ground side. Not the case on a lot of Asian ones. They actually are all grounded. You'll just see one wire going to each solenoid because they're all grounded through the valve body when they're bolted on, and they're actually power controlled. So if you get inside a valve body on an Asian vehicle and you see just one wire and everything, that's why. Whereas the domestics have two wires, they're all controlled by grounds, okay? So basically, you got your power through the fuse, gets to the PCM. Now the PCM has to deliver power. Like I said, on a domestic vehicle, all the solenoids are going to be powered up. So let me draw. We'll just draw a little connector here. All right, and then what do we got here? Generic connector. But what we're going to have is a power supply that's going to run through a fuse. So if it burns out, it doesn't hurt anything. It comes out of the PCM, goes through a fuse. So you'll have your transmission fuse, we'll say, for the transmission controls. It's going to come out of here, and it's going to go, say, into the connector. And inside the connector, it's going to come out. Obviously, it's going to vary on each vehicle, whether it's in the connector, in the harness, whatnot. But it's going to come out, and what that's going to do is it's going to supply power to all three solenoids, okay? So like a Chevy, a 4L60, the solenoids, except for a PWM, that's a whole different topic, pulse width modulation and linear solenoids, that kind of stuff. We're just talking about on-off solenoids, shift solenoids particularly. They're all voltage supplied, okay? And they're going to be controlled by the PCM with the ground. So PCM's getting its ground from this ground here, which could be a body ground, it could be an engine ground, could be a straight ground on a harness. They're supplied many different ways. But you've got your ground. Now the PCM will say shift solenoid. We're going to call this shift solenoid 1, shift solenoid 2, and we're going to just call this lockup, TCC, just on or off, not PCM or not PWM or anything, just an on-off solenoid. What the PCM is going to do is we're going to say this is shift solenoid 1 ground, 2, and then TCC. So you're going to have 2. The ground is on its own. They're not shared because it's got to individually control it. And then it's going to go out of the connector to here. Okay? Shift solenoid 1, PCM is going to control the ground, come through here and to here. And then TCC, we're going to go over that so we're not connected to it. Around. All right, now we got ground supply to the TCC. So if you're trying to determine whether you have an electrical or mechanical problem, there's a few things to look for when you get your codes. You're going to hop in a vehicle. They're going to tell you, let's say it's not shifting first to second. We'll use 4L60 for example, easy Chevy transmission. Typically, if you understand how they work, you're going to say, well, it could be a band problem. That's what comes on in second. It also comes on in fourth. So it could be a band, servo, could even be a valve hanging up. Could be the valve or the solenoid itself inside hanging up, which would be all mechanical issues. Or it could be electrical part of this system. We need to determine which one, before we pull the transmission out and start tearing it apart. Is it just a simple solenoid? Which for some reason most AutoZones and everybody that scans them says, oh, you just need a solenoid. You have a solenoid code. And for example, we're going to say shift solenoid 1. We have a code, circuit high. Okay? So we're going to say a circuit high code, shift solenoid 1. What does that mean? Circuit high means it has its power, it's missing its ground. Okay? That's what that means. So it could be losing its ground here. But if we're losing our ground before the PCM, we're going to be losing all our grounds, okay? They'd all be throwing codes. We only have a code for this one losing ground, which basically we can say, all right, 3 options. The solenoid has an internal problem. It has a problem with the internal harness in the valve body, the connector, the harness back to the PCM, or the PCM is not closing that driver to command that, okay? So what we can do is there's points we can check. Make sure we have a good ground here when it's supposed to command it. You can do that with a voltmeter or a scope. You can connect onto your PCM and determine and see if it actually completes a circuit. If you have power and you put your ground probe there, it'll actually complete the circuit when it closes, and you'll see your voltage. You can test it here. You look at this connector, same spot, test it here. But if you've got a circuit high, which means you're missing the ground, probably not a servo or a band. It's not going to need a transmission. Not particularly. If it's the opposite, if it's circuit low, you've got your ground, you're missing a power. Now here's the nice thing about that is on a domestic, if you're missing your power, what does that tell you? You know it's not here, because you'd have no power, they'd all be throwing codes. It's either the solenoid itself is bad, shorted out, or in the internal harness it's bad because it would lose its power there. If you had a blown fuse or any of this, you'd be missing power in all of them. They'd all be throwing codes. So if you just have solenoid 1, circuit low, you're missing power just for that solenoid. Chances are it's a bad solenoid or the internal harness has an issue, or then the connector, depends on how it gets it. But it's not going to be the fuse. It's not going to be the PCM typically because it's supplying everything. So you can eliminate that, which is nice. And you can do the opposite for Asian vehicles. They're always all grounded together. So if they're all throwing ground codes, you know you're not getting a ground there for some reason. And then they're controlled voltage-wise. So you can do the opposite to narrow down what you're looking at, okay? Now, how do you know if it's a mechanical issue? Let's say we get shift solenoid 1 performance or stuck on or stuck off, one of those codes. Typically, that's going to be a mechanical issue. The tricky part is figuring out what it is. If you're getting a mechanical code stuck on a performance code, your powers and grounds are going to be good. You can double check them, but because you don't have the electrical code, chances are it's going to be the actual solenoid. And how a solenoid works is, let's just give you a little rudimentary solenoid. There's a little valve in here. And you've got your coils. And you got power and ground, okay? And when you constantly have power on this, and then you turn on or off the ground, what happens is you complete electrical circuit, the electricity is going to go in through the coil, which creates a magnetic field around a core that's in there, all right? You're going to get a magnetic field, and it's going to, there's different ones that are open, always closed. They'll do different things, but so you need to know what solenoid you're working on. But it'll move that valve to either allow oil through. You got transmission fluid that's trying to get through, but there's a valve there. There's a path, When that valve moves over, then fluid can go through, or vice versa. It might always be open and it closes when it comes across. So like I said, there's different solenoids, but you're creating a magnetic field which draws that valve in. That's how a solenoid works. So a performance code, that little valve could be stuck in the solenoid. You could have, and then a lot of times what they'll do is fluid will come through the solenoid and you'll have a valve, a shift valve that sits in a bore. So fluid's going to come out, it's going to move that valve over, which then can allow fluid that's trying to get through that's currently blocked. When that valve moves over, now the fluid can continue through. So it'll allow pressure to come through or exhaust off. They have different purposes to move a valve. The newer stuff's linear solenoids. They're doing away with valves, which is kind of nice. So if you have a performance code, you could have a valve that's hung up. You could have the prindle inside the solenoid that's stuck. When the fluid goes through and that valve moves, it moves to a servo or a drum full of clutches. I don't want to get too deep in transmission, full diagnostics. But now you know if you've got a performance or stuck code, you would have to take the solenoid out and test it, which there's a way to do that. I'll do a video on it one day. But you take that out, if it's not a PWM, and test it on or off. If you kind of need to look and see if you ohm these out, I'll give you a quick little tip without going in detail. If you were to ohm this out, and let's say it's 4 ohms, and you know it's a 12 volt supply, you can divide the 12 volts, divide that by 4, and you're going to get a 3 amp draw on that solenoid, okay? That's Ohm's law. So what you can do is take the solenoid out, apply 12 volts, and check with a voltmeter in between. I have a nifty little tool that tells me when I apply power and how many amps it's drawing, but you can do it with clamps and alligator clips and test this. But if you apply 12 volts to a 4 ohm solenoid, it should draw about 3 amps. And you'll hear it click. You're going to see it click and hear it click. So you know it's moving. If it's clicking, you're going to see the right amperage drawn. If you apply it and there's no power, then you know this is bad, okay? Or it tries to draw more. I'll have a better video on that. This is just kind of like letting you know whether it's electrical versus mechanical. But that's typically how a lot of domestic ones work. They're all power supplied, and they use grounds through a PCM driver to turn solenoids on and off, depending on, engine load, throttle position, accelerator pedal position, those kind of things to determine when it's going to shift. They no longer use governor and governor pressure like the old days, which I'll do some videos on them older ones, but they're not, you don't see them as much, especially in dealers, you don't see them at all. They're all electronically controlled. But that's the difference between electrical and mechanical failure. Now, you can have a band that's bad, or a servo when this fluid goes through and it's trying to apply a band, let's say 4L60 for second gear. PCM's going to command that solenoid to come on. It's going to open, fluid's going to go. It's going to go to a servo, try and apply the band, and nothing happens. You don't have second gear. It's going to throw a performance or stuck code because your transmission doesn't have sensors that look at the band and at the servo to make sure they worked. All it knows is it commanded this solenoid on or off, depending on what it needs to do. And the shift didn't happen because of gear ratio. The computer has programming in there to know vehicle speed, gear ratio, that type of stuff, based on speed sensors to know whether it's shifted or not. And it's going to throw a code. Hey, we told solenoid, do its job, it didn't. We didn't shift. It's not seeing a ground or power shift, so it's not going to give you electric code. It's going to give you a performance or stuck on or off code. Same thing can happen with a converter clutch solenoid. But yeah, misconception is people think, well, there's a sensor should tell me if a band's bad. There's no sensors that tell you the band's bad. It knows it commanded it. Nothing happened. So the only thing it knows is, okay, we know the electrical is good. We don't need an electrical code. We're going to give you a performance code. So it narrows it down. Okay, whatever shift solenoid one controls that hydraulic circuit, you can narrow it down. Typically on a 4L60, when that solenoid comes off, they're both on when you take off, but when it comes off, fluid comes through, band comes on, does the same thing again. It comes back on for the band to come back on a different way. But you can kind of narrow it down. So if you ever have electrical, circuit high, circuit low, you need to look at the electrical system. Don't pull the tranny out and rebuild it. You need to fix that first, Then you can drive it to make sure if there's actual transmission issue. Okay, so that's your little tip today on electrical versus mechanical transmission diagnostics. So thanks for watching. I'll see you next time.